Okay, at the end of yesterday's class, we were doing finishing example 2 from your last storm day, actually, on the sheet free-falling problems. And we were talking about part D. What will be its speed? When will its speed be 20 meters per second? And we talked about the fact that if you're throwing it up at 5 meters per second, then as it goes up, it slows down, it slows down, it slows down, and it stops up here. So if it starts at 5 meters per second and slows down until it stops, it's not going to reach 20 meters per second on its way up. And then it starts to fall back down and speeds up, speeds up, speeds up. When it gets back to the spot where you've thrown it, its speed here will be the same as what you threw it with, just in the opposite direction. So its speed here is going to be 5 meters per second down, which means it still hasn't gotten to 20 meters per second. So to get to 20 meters per second, it has to fall further. So what we've just answered, actually, in saying the 5 meters per second there is, what will its speed be when it gets back to your hand? It'll be 5 meters per second down. But now to do part D, and it wants to know when, so we're looking for the VF to be 20 meters per second, and we know it has to be down. And we know the VI is 5 meters per second up. And we know A, of course, is gravity, 9.81 meters per second squared down. And we're looking for time. So you can just use your equation, A is equal to VF minus VI over delta T, and rearrange it. Delta T is equal to VF minus VI over A. And just be careful with your directions, positives and negatives. So assuming we call up positive, then the 20 meters per second will go in as negative, minus the 5 meters per second will go in as positive, and acceleration will go in as negative. And so you end up having negative 25 on the top, divided by negative 9.81 on the bottom, and you should get 2.5484 seconds for when it's going to reach the 20 meters per second, which is significantly bigger than what we found for the total time it took to get back to your hand, right? Because it has to go beyond your hand, so it's like you're standing on a roof throwing this object. Okay, so that's the end of example 2. I asked you to do last night example 3 and 4 on the back, so let's take a look. Number 3 says a hot air balloon is rising at a speed of 30 meters per second. Okay, so here you are, you're in a basket. This is the hot air balloon, misshapen because of the words, not because of my drawing ability. And the hot air balloon is going up at a speed of 30 meters per second. And it says a person falls out, sorry about that, of it when the balloon is 500 meters in the air. Okay, so here's this person looking over the edge, waving, "Hi, Mom," and then they fall. All right, they have a parachute on, no worries, but for the sake of this question, they're not going to pull the parachute, of course. So when they fall, their initial speed is actually 30 meters per second up, because they were on their way up when they fell. The A will be 9.81 meters per second squared. Gravity, and that's down, because that's what gravity always is. It says they're 500 meters in the air, so the distance they have to fall is 500 meters down. And the first part of the question wants to know what's their speed when they hit the ground. Okay, so you have VI, A, delta D, and you want VF. So of course you are all saying right now out loud, VF squared is equal to VI squared plus 2A delta D. And you don't even have to rearrange, you just need to look after your positives and negatives because of the direction. So VI will be positive 30 meters per second squared plus 2 times negative 9.81 meters per second squared times negative 500 meters. The two negatives, of course, are going to make that last term positive. So 30 squared is 900 meters squared per second squared. Negative and negative is positive. 2 times 500 is 1,000. So this will be 9810 meters squared per second squared. Add them together and then take the square root. So 900, so 10,710 meters squared per second squared, and then don't forget to take the square root. And you get his speed is 103.489 meters per second. Guess he should have pulled that parachute string because that's kind of fast. Moral of the story, don't fall out of a hot air balloon a half a kilometer above the ground. How long will it take for the person to hit the ground? Okay, so you could use your delta D is equal to VI delta T plus 1/2 A delta T squared. But if you do, it's going to be a quadratic because this time the VI isn't 0. So you could do it this way because you can all use the quadratic, but I would probably go with the easier route. A is equal to VF minus VI over delta T. Because you just found the VF, and it's true, you might have screwed it up, but you also could easily screw up the quadratic. So 6 of one, half a dozen of the other. So I would go with this one because math-wise it's easier. VF minus VI over A. This VF, of course, is down. So it needs to go in here as negative 103.489 meters per second. Minus his VI is up 30 meters per second. And A, of course, is down 9.81 meters per second squared. Okay, so the two on top actually get added, so it'll be negative 133.498 divided by negative 9.81. And you get that it takes Buddy 13.607 seconds. Plenty of time to pull the parachute. Or maybe to get the trampoline out at the bottom. Okay, so that's example number 3. Number 4, the same hot air balloon is rising 25 meters per second. Okay, so the V is 25 meters per second. If an object which falls out of the basket takes 8 seconds to reach the ground, how high was the balloon when it fell? So you're looking for delta D. This will be up, and of course A is 9.81 meters per second squared down. So again, if the object is in the balloon as it's rising, when it falls out of the ground, that becomes the object's VI, because that's the speed it's initially going when it falls. All right, so this one's a one-stepper. It's easy. It's just going to be delta D is equal to VI delta T, 1/2 A delta T squared. No need to rearrange. Positive 25 meters per second, 8 seconds, plus 1/2 negative 9.81 meters per second squared, 8 seconds squared. Delta D is equal to, so 25 times 8 is 200 meters, minus 4.905 times 16 is 78.48 meters. So delta D is going to equal 121.52 meters. And I did that in my head, so hopefully I didn't screw it up. Minus 121.52. I didn't. Okay, so those are the 3 examples. Finishing that sheet. So then I asked you to go to the free fall sheet, numbers 8 to 12. And so that's what I'll do in the next video because this one's out of time.